Okay, let's work our first problem. We're looking to see if this function is one-to-one. We know that a function has one output for each input. Well, to be one-to-one, it works the other direction. For every output, you have to have exactly one input. So let's just check this one out. So we look at our data, and this time we look at our y values, our output, and we look to see, do any of them repeat? And we can see that our output of -7 does repeat. And the input that's related to each output is different. So this is not one-to-one. To be one-to-one, your output has to have the same exactly one input. Another way we can verify whether this is one-to-one is we can use the horizontal line test. Now don't get confused. The vertical line test is to determine if it's a function. The horizontal line test is very similar. If it passes through more than one point in the function at a time, it is not one-to-one. Let's try the next one. So first, I always look to see if the output repeats. So I have 17, 19, -5, and -13. So my output does not repeat. So each output has exactly one input. Therefore, this is one-to-one. And our function could be given in a tabular form. Once again, the first thing I do when I'm checking for one-to-one is I look at my output and I say, do I have any repeating outputs? I do. The output 11 has two different inputs. Therefore, it is not one-to-one. This time we're given the function as a graph. And we already mentioned that the horizontal line test says that a function is one-to-one if no horizontal line intersects this graph more than once. So just like the vertical line test, we do the same thing, but this time we use a horizontal line. And it needs to intersect only at one place at a time. And you can see that this will. So yes, this is one-to-one. Let's try another one. What do you think? Does this function, let's back up for a second here. Hold on, let's read this problem. Does this graph represent a function that has an inverse? So first of all, to have an inverse, you must be one-to-one. So first we're going to check to see even if it's one-to-one, and I can check that by using the horizontal line test. And you can see that if you put a horizontal line anywhere on this graph, you're going to only intersect at one place at a time. So yes, it is one-to-one. And so we know that it does have an inverse. Let's try the next one. Does this graph represent a function that has an inverse? Once again, we could use the horizontal line test, and we can see that already it fails. So no, it is not one-to-one, and therefore does not have an inverse. Okay, this time we're given a function, and now we're given it as points. Be very careful here. This is not continuous. These are discrete points, which means they're just dots on the graph. And I can tell that because of the set notation for the brackets. So all we need to do is swap the output and the input. So this is not a problem. We say instead of -3, -15, it's going to be -15, -3. And instead of -1, -9, it's going to be -9, -1. And so on. Here we go. Now we know that the inverse, so let's find the domain and the range. Now, I want to make sure you understand, because a lot of people got this wrong on the very first test. When you have just points, then your domain and your range are going to be just in set brackets. So you're going to have these set brackets. If your function or your inverse is continuous, it's not just points, then you're going to use interval notation. Okay? But when you're just given points, you're just going to say that the domain are the x values and the range are the y values. So my domain will be -15, -9, -6, and 9. And my range are my values that are my outputs of my inverse. So it's going to be -3, -1, 0, and 5. And notice I leave them in this set brackets since they're distinct points in my inverse. Number 17 is exactly the same problem. It's just given in function notation. But we know that this is always my input, right? And f of -4, this would be my output. Would be 6. So in other words, function notation just tells me a point. So I'm given 3 points. This is my function. I want to get my inverse. So for my inverse, I just swap the x and the y. Now I want to give my domain and my range of my inverse. So for my domain, I'm going to have 6, 8, and 11.5. And for my range, I'm going to have -4, 0, and 7. Now we're going to find the inverse of this continuous function. Step 1, replace f of x with y. Now, it may be given as y, and in that case, you can skip this step. What they're saying is just cross this out and write it as y. Step 2 says swap the input and the output. And that literally is what you're going to do. So wherever there's a y, you're going to hit x. I'm going to rewrite this as x is equal to -3y minus 11. You can see that where I had a y, now I have an x. And where I had an x, now I have a y. Now, we're going to solve for y. So I'm going to add 11 to both sides. And I'm going to divide both sides by -3. And I get y is equal to x plus 11, all divided by -3. You could write it in different forms of that too. If you wanted to, you could write it as -1/3 x minus 11/3. Both are correct. But your last step is very important. You have to make sure you change out your y for the inverse of x. And this is how we write the inverse of x. So we know that is equal to -1/3 x minus 11/3. Let's do another one. So we're going to want to write the inverse. And the way we do it is we replace f of x with y. Now, to find the inverse, we're going to swap x and y. See that I just changed out y for x here and x for y here. Now, we're going to take this function that we've just written, and I'm going to now solve it for y. So I'm going to subtract 5 from both sides. And I'm going to multiply both sides by 2. But I'm not finished. This is the big gotcha. You got to remember, the very last step is to replace y with the inverse of x. So my inverse of x is equal to 2x minus 10. Now our next problem gives us a function and it asks us to graph the inverse. So we have to know a couple of things. First of all inverses are symmetrical about the identity function. So they all are symmetrical about the x is equal to y axis. I graph that function in. So this is going to be y is equal to x. Okay? Now to graph the inverse, all we need to do is find some points on the red function and swap their inputs with their outputs. So for example, I've just labeled 3 points that are on my function. 2, 4, 1.5, and -2, -4. I'm going to graph the swap of the output and the input. So instead of 2, 4, I'm going to graph 4, 2. And instead of 1.5, I'm going to graph 0.51. And instead of -2, -4, I'm going to graph -4, -2. I can use these points as guides for me to draw in my inverse function. And you can see I sketched in my inverse in purple, and they're symmetrical about that y is equal to x axis. Now, when I say this, I mean if you were to paint red paint onto the red function, and then you folded your paper along that diagonal line, and then you open it up, you would get the purple function on the other side. It would make that, that symmetrical image about x is equal to y. This is a word problem, so I'm going to ask you to stop the video and actually read, pause it, the word problem. Okay, so you read it and hopefully you're understanding the problem. You can see that what's happening is these Girl Scouts are having to pay $125 for just miscellaneous expenses, and then they're getting charged an additional per basket fee. So part A asks us to write a function in terms of the number of baskets sold. So our cost per basket will be $125 plus 5.5x, where x is the number of baskets. Now, let's think about our domain. We can never have negative baskets. So our x has to be greater than or equal to 0. Because if we have 0 baskets, then we're going to still pay the $125. So we have our function for A. Part B says, what is C at 95? So all you need to realize is that the 95 is our input, which is our x. So we're going to replace x with 95. And when I evaluate that, I get $647.50. Part C says, use your grapher on your calculator to graph this function. Include your selected window and label the axes in the context of the problem. Okay, let's graph this problem. So I've gone ahead and put this into my grapher under y equals. Then I changed the window. We know the smallest x we're going to need is 0. And we don't know how many baskets they're going to sell, but possibly up to 95. Let's just say 150. Okay. And our y would also be a minimum of 0. And if we put in 150 for x, then what will we get? We'd get 950. So I think I'm just going to say, let's just say 1,000 for our maximum y. So now we can look at our window, look something like that. If we wanted to label our axes, we'd know that the x-axis would be the number of baskets and the y-axis would be the cost. And it says, why is this 1-to-1? Well, you can see that it's 1-to-1 because it passes the horizontal line test. Now let's find the inverse function. Okay, so we're looking back at our function in part A. We're going to replace c sub x with the letter y. So this is our original function. Now for my inverse, I'm going to swap the x and the y. And I'm going to fill in everything else. So you can see our y became an x and our x became a y. This is my inverse function. I just now need to solve for y. So I'm going to subtract 125 from both sides. Let's bring this over here. So it's going to be x minus 125 is equal to 5.5y. And I'm going to divide both sides by 5.5. And then my last step, wherever their y was that we solved for, now we're going to replace it with the inverse of x. And there are other forms you could write this in. You could write this in many various forms. For example, you could make this into a decimal and do a decimal equation. It doesn't matter. Okay, so this is my inverse. Part E says, find and interpret the inverse of C at 500 in terms of our problem. So now when you're looking at the inverse, you have to realize that the input no longer is baskets. Now the x and the y have been swapped. So my input now is going to be my cost, right? So in other words, if I solve this now, if I evaluate this for an x of 500, I get 68. This is not cost. Instead, this is the baskets. So you can see on an inverse, your x and your y are swapped. You're undoing the problem. So this means that when the cost is $500, the Girl Scouts will sell 68 baskets.